dear students. This is Dr. Osama, your teacher, and this is the third lecture in hypothetical tests. And today we are going to move forward to talk about a new topic or a fully example for what we are working on right now. So for going now for this example, let me share the screen first. Then okay. We have here an example is about the school nurse thinks that the average height of the 7 grades had increased. She thinks that it's increased. The average heights of the 7 grades 5 years was 145. So now I will go step by step. Now I said this is 145 is the average of the population. So I will say mu equals, you can do it equals or greater than 145. You can say it mu equals. Okay, let us see here. The first thing is to go for the hypothesis null. And the hypothesis null is, I will do it like this. I will do the hypothesis null that way. Okay. Hypothesis null. Well, let me stop sharing the screen, then go to the board. That's fine. Okay. She said that the school nurse thinks the average height of the 7th grade is increased. The average height of the 7 grades 5 years was 145. H1, I can say mu equals 145. Now this is H0. H1 will be based on what is there in the example. On the example, she's saying, let us go to the example pack and share the screen. Sorry for that, because it's very vital to share the screen at this point. She's saying that okay, she's thinking about that it increased, has increased. So this is the claim that it has increased. For that reason, we will take H1 will be more than 145. More than 145. So here, H1, I will stop share because she said increased. The population is more than 145. Then H1 will be mu greater than 145. Because of the word when she said the tall or the height increased. So because she said increased, I here make it greater than. This one I can make it less or equals 145. Less or equals, but it's for cute better is to make it equals 100. That she thinks that it is not less than 145 means 145 or more. So we can make it as example like this. 140, but it's better to just make it equals that she believed so that we can compare those two together. Like you see here, this will be one tail test. One tail test. And we'll check for the confidence right now, and we'll check for the confidence how it will be. One tail test because the sign, the variation of the, because of the variation sign, always when there's a variation sign, it's only one tail test. Okay, let us go and take, because this, the hypothetical test, you take from every sentence, the numbers, you will get use of it in solutions, in getting your own solution. Like as example, every number has a very important for the student to extract meaning from it. So now this is, we said, okay, the average height of the grade 5 years was 145 centimeters with a standard deviation of 20 centimeters. Hey, wait a minute. I have the standard deviation of the population here. The standard deviation, we signal to it with the word or the letter sigma. So I have now given to me that the standard deviation or sigma equals 20. Sigma equals 20. Sigma, we make it a sign like this, sigma. We call it sigma, and it's 20. Okay, sigma is 20. Okay, but wait a minute. So sigma is known and the population is great because the sample is great, it's more than 200, then in that case we will take z-test. Okay, she takes a random sample of 200. Look at this. She takes a random sample of 200. Let me share the screen back and forth here because it's very important to share the screen, because in every step I know I'm getting used or taking a chance, taking advantage of every sentence, taking one thing that I will write here. So she said, we know now the standard deviation is 20. We wrote it here down. Okay. She takes a random sample of 200. So n is a symbol of the sample. We use n to express the sample. We use n to express the sample. So the sample is 200. That's fine. Perfect. Sample is 200. Okay, okay. Then here I will say n, stop share, and just show you what I will do with those data, how I will use the data, like in doing the example. I will say n will equals 200. Usually, for my dear students, we have two kind of tests. It depends what the kind of test, what table I will look in. What is the table in which I will look? We have z-test. We have z-test. And we have t-test. Okay. When I would use this test in such a case, I would use z-test. Why? Because sigma is known, sigma of the population. Sigma of population is known, and the n is greater than 30. The sample is greater than 30. In that case, I will use z-test. In that case, I will use z-test. But if sigma was unknown, or they give me the sigma of the sample only, and n, the sample, was less than 30, then I will use t-test. I will use t-test if sigma is unknown, is not there, sigma is not there, I don't know it, not available, NA, not available, sigma of the population, because I will have sigma of the sample, I don't care about the sigma of, I'm caring about the sigma of the population. As long as the sigma of population is not there, and the sample is, N is the sample is less than 30, we use t-test. What is the difference between z-test and t-test? Actually, both of them are tables, different, D-I-F-F-E-R-E-N-T, different tables. So when I work and I have sigmas known and n is greater than 30, I will go to Z table test. Z table. If sigma is unknown, and the sample is less than 30, then I will go to t-test. I will do t-test, or the table of t. Here, the table of Z, here, the table of T. And this is the difference between both of them. What it's only in the differs in the systematic and the rule and the formula is the same, but only it will differ in which kind of table I will use. Again, if sigma of the population is known, sigma of the population is known, and the sample is greater than 30, then I will go to Z table. I will go to Z table. Z table. If the population standard deviation, or the sigma is the standard deviation. Sigma is the standard deviation. If the population, if the sigma of the population is not known, but he will give me the sigma of the sample. No worry about this. It's okay. It's there. I will use it instead of sigma of the population. I will use it instead of sigma of the population. If sigma or the standard deviation of the population is unknown, I don't know it, and the sample is less than 30, then I will go to T tables, not Z tables. I will go to T tables in this case. And that's what's different between both of them actually. The only difference between both of them is based on the sample size, greater or less than 30. And the standard deviation of the population, is it there? There I will use Z test. Not there, I will use T test. And Z test and T test are tables. I will look in Z, in table is called Z, a table is called Z, right now we will see it, or I will look in a table that's called T, and right now I will see how we will work on the T and Z. Okay. Now let's go back to share the screen and complete the example. Okay, I know that the sample is N is 200, and I know that I formulated the hypothetical 0 and the hypothetical 1, or the alternate, and I know that the sample is 200, N is 200, and the standard deviation of the population is 20, or the standard deviation of the population is 20 here. Okay. She takes a random sample student and find that the average height of her sample is 147 centimeters. Okay, you mean it's 145 in the population, and in the sample it's 147. So in the sample is more. In the sample is more than in the population. The population are all the students. The sample are the sample which she took the 200. She found that the height of this student, she measured them. She found that the height of them is 147, which is more than 145. For that reason, look at this, the hypothesis alternate. Mu1 is more than 145 because she found them more 147 centimeters. Again, for my dear students, I will repeat back, no problem about repeating, because this is the basics itself. She found that in the sample 147, which is greater than, look at this, at hypothesis A here, then mu1 will be greater than 145, like you see here, greater than 145. Because of what? Because it's 147 here, and here is 145. And also because of one thing, because she said at the start that she believes that the average increased. And this is the proof that the average of the height is increased. For that reason, we did the hypothesis, like I told you in lecture 1. We formulate the hypothesis 1 based on what you have in the example, based on the context. Is it increasing? Then it will be greater than. Is it decreasing? It will be less than. It is not the same, then it will be unequal. Okay, okay. Then now we have to go and put our test. How we will formulate the test. This is the third step, which I will show you today. How we will formulate our test. We will do Z test here. We will do Z test here. Okay. I will do the Z test. Okay, now I will do the Z test. I will stop share and I will do the Z test. Okay. The Z test is telling me here, it's the test. I did the hypothesis, the test tool. I will use now the test. Test tool is Z. Because we see that the sample is known, 200, sample is 200, and sigma is 20, sigma of the population. For that reason, I will use Z. Z is greater than. Okay, you will see here in the text, it's like this. No worries, it's okay, like this. But it's in the formula here, greater than, so we can be punctual more and make it greater than. X bar, and I will say everything now, what is the meaning of this? Minus mu divided by sigma divided by the root of n. Okay, where yes? Whereas X bar is the sample average. X bar is the sample average. Mu, we have mu. Mu is the population average. Mu is the population average. We had it. It's okay. Sigma, we have sigma. Sigma is the standard deviation of the population. And n is the sample. So what? So we'll substitute now. We have to substitute. We will work now on the substitution. Okay. How will I substitute here? I prefer to write it actually here, guys, so that everything will be clear in front of you, so the comparison will be very clear here, because the board is very good to show. Okay. X bar, she said the X bar. She said the total, which is 147, because X bar, or the average of the sample, the 200 students, she found the sample. She found in the sample, the X bar, that the total of this, the height of this students is not 145, it is 147 centimeters. So X bar is the average of the sample. I will write it here again, here in this part. X bar is the average, or the sample average. Sample average. Now, when we substitute, everything will be very clear. So X bar is the sample average. Perfect, very perfect. So now, when I substitute Z is greater than, X bar is 147, which is in the example, minus the mu. Mu is 145 divided by sigma. Sigma is 20 divided by root of 200. Root of 200. This is when you substitute in this formula. When you substitute in this formula, you will find that X bar is 147, X bar is 147. Let me make it in another color so that it will appear more. Let me make it in another color. Okay, I just want to use this space in their board to make it. We'll substitute in this formula now. I'll substitute with the red or the blue pen. X bar is 147. X bar is 147. 147 minus mu is 145 divided by the sigma. I know the sigma is 20 divided by the root of n. The root of n. Okay, I have the sample. The sample is 200. Okay, that's equals. After you finish all your calculations, you will find it will equals 1.414. Will equal this value 1.414. Okay, will equals 1.414. Okay, 1.414. This after we said the second step, and we had first the hypothesis nil and hypothesis 1, and we had the test tool. Now we will compare between Z tabulated and Z calculated. We will come to the comparison between both of them, between Z calculated and Z tabulated. This is the step 1. Step 2. Step 3 will compare Z tabulated with Z calculated. how I will do the comparison between Z tabulated and Z calculated. I had already Z calculated is Z calculated equals this value 1.414. To get Z tabulated, I have to check first. Look at this. To get the Z tabulated, I have to check what is the degree of the confidence in the example. I have to go to the degree of the confidence first and see. So for that reason, I will share the screen and see the degree of the confidence. She said on degree of confidence is 5%, is alpha is 5%, means that you, so the degree of the confidence here, your degree of confidence here, Z tabulated with 90, C equals 95%, and alpha will equals 1 minus C equals 1 minus 95%, then alpha will equals 5%. And I care about the alpha. Okay. And we have here, as long as we set greater or, I don't want you to care about right tail or left tail. In the two cases, greater or less, this is one tail test. This is one tail test. When we go to look at for this, because it's one tail test, let me stop share. I repeat back what I did here just now. I'm working on this part now. I'm in the third step to compare Z tabulated with Z calculated. I'm comparing Z tabulated with Z calculated. Okay, Z calculated, I got it, it's here, 1.414. Here it is, 1.414. I got it from applying on the equation 147 minus 145 divided by 20, the sample, the standard deviation divided by the sample 200 roots, the root square of 200. So I got 1.414. So for getting the Z to get, this is the Z calculated 1.414. Okay, I want now to get the Z tabulated because I have to compare the Z tabulated with the Z calculated. I have to compare them with each other. So I would say, he gave me in the example, like I showed you, he gave in the example that alpha equals 5%. And I know that this is one tail test. I knew this. From where I knew that this is one tail test? Because of the sign of H1. The sign of H1. As long as it's greater than, then it is one tail test. Or less than, if it is even less than, then it's one tail test. When I go to Z tabulation under 5% alpha, like as example, let me show you here. I go like this, one tail on 5%, okay, 5%, and I will check, I will find it that the value is 1.6416. Let me double check it. I will find the value of, and I will show you now the tables. The value is 1.64. When I look here, it will be 1.64. When I look in the table, I will find that the value is 1.64. Here it is. I will repeat it here. I'll go under 5%. Alpha is 5%. I will find this number, one tail, 1.64. This is the Z. This is the Z calculated. This is Z tabulated. Let me stop sharing and I will repeat it back I will repeat it back. I knew now that I'm working on one tail. I know I'm working from one tail because of this sign. Sign greater or less than, this is one tail test. Okay. One tail test and the degree of confidence is 95%, which means is alpha 5%. Then alpha 5%, one tail test, when I go to the table, I will find this number, 1.64. Then this is the Z tabulated. Z tabulated will equals Z tabulated when C or when alpha is 5%. One tail test will equal 1.64. 1.64. Okay. Now we'll compare the Z tabulated with Z calculated. Like this step, we have to compare between Z tabulated and Z calculated. So when I compare, I will see that the Z tabulated is greater than the Z tabulated. Z tabulated, Z calculated, Z calculated, let me use a good pen. Z calculated is less than Z tabulated. Then it goes in the area of accepting. Okay, let me just draw it. I want to draw it. I can draw it here as well. In this part, I want to show you what is the meaning of the calculated and tabulated and how we will measure between them. So here as example is the normal distribution curve. And here is the middle. And here is the area of the acceptance, 1.64. This is the Z tabulated, Z of the schedules. Okay, so in this area, I will accept any value here in this area, any value in this area, I will accept H0. Okay, I will accept H0. So in this area, when I come to calculated, the calculated is 141. 141 is still here in this area. It's still 1.4. The tabulated, the calculated is 1.414. So it goes inside this area. That means I will accept H0. Again, because some students might didn't understand it, or for repetition, I will compare between Z tabulated and Z calculated. That's what I will do. Okay. To compare them, the point is that 1.64 is the tabulated. Here it is. If I draw it like this, this is the normal distribution curve, and I accept till 1.64. To this area is the area of acceptance. So any value goes within this area from 0 to 1.64, from 0 to 1, then I will accept the hypothesis null. I will accept the hypothesis null. Okay. So the value which I have is 1.4. Wait a minute. Compare 1.4 with 1.6, regardless of the other numbers. 1.4 is less. The calculated 1.4 is less than 1.6. Okay, so I came here in this area, which is the area of acceptance. Acceptance of what? Acceptance of H0. I will accept. Then the decision, I will make my decision, accept H0. The final step is decision. I will write it here. Decision. I will accept. Here we go. Step number 4. Decision. DECISION. Accept I will accept H0 because 1.4, the calculated 1.414 is less than 1.64, is less. So it goes in the area, inside the area. Till 1.64 I accept. Till 1.64 I accept. Any value that is less than 1.64, I will accept H0. I will accept H0. So it's 1.4, which is less than 1.6. So in that case, I will accept H0. And here I will say that what is in H0? H0 that the mu is 145. So accept H0 means reject H1, which you reject H1 in that case. Okay, this is the summarizing of this example, and we'll go forward after this to watch another examples more, but this was for the moment. So let me remind you back with the steps which I did here. The first of all, I said the researcher is having 100 students. She believed that they became more than 145 centimeters. So she checked H0, H1, and we made the test tool here. Z is greater than x bar minus mu divided by sigma divided by the root of n. Then we compare, we substitute in the formula, and we get the results that Z calculated is 1.414. We compare the Z calculated with the Z tabulated. Z tabulated in the table, we will get it under the error 5% or alpha 5%, and it's one tail test. The value will be of the tabulated is 1.64. Here is 1.64. Then this will mean that I will accept H0 and refuse or reject H1. This was the end of this example. Thank you so much. And yeah. Okay. And if I show you also how to interpret, simply you can say that we will accept, because it's in the critical area, we will accept H0. That's what you will say. So like here, we said it's smaller, 1.4 is smaller than 1.6, like we did here, and thus does not fail the critical area. Our decision is to fail to reject the null hypothesis, okay? Okay. And conclude that the probability of obtaining sample mean equal to 1 is likely to due to chance only, but it is not right. So the student's height is still 145, and what comes 47, 147, this may be by chance, but it doesn't make sense. So we accept H0 that it is 145. Shall see you in the next video. Please stay safe, take care of yourself. I hope that you understand the steps. Let me tell you the steps back. We formulate H0 and we formulate H1. After that, we moved on to, let me show you here, like this example. We formulate H0 and we formulate H1 or H alternate. H alternative is based on what is in the example and what's talking about the claim. The claim that she said here that the height will be more, and she found in the sample they are 147. But that at the end we discovered that this was not, this only due to chance, but was not because it's a fact. It's a fact that the people became taller 2 centimeters. No, it's not a fact. Okay. And we know what is the meaning of H when we take every thing and substitute. And we know when we will use Z table and when we will use T table. We use Z table always when we have the standard deviation of the population and that the n or the sample size is greater than 30. Then we use Z test. But we use T test when the opposite, when the standard deviation of the population is unknown and the sample size is less than 30. Here we use t-test. And we know what is the meaning of one tail test and two tail test. One tail test means if the hypothesis 1 is greater or less than, then it's one tail test. Regarding of to the right or to the left, the value is the same. And we know now that the decision, we will compare between Z tabulated, which you will get it from the tables, and Z calculated, which you will get it from the formula, from this formula here, from the formula. You will compare between them. Then if Z calculated is less than Z tabulated, in that case, you will accept hypothesis nil and refuse or reject hypothesis 1. If the opposite, if Z calculated is greater than Z tabulated, which means that it does not go in the critical area, then in that case, you will reject H0 and accept H1. Shall see you in the next lecture. Stay safe. I hope that you understand it. Please, these kinds of videos, you have to repeat it once and twice and 3 and 4 times, because it's a protocol of answering the question. It needs from you some effort to understand it and to repeat it till it gets to be very memorized in our brains and totally comprehended. Shall leave you in safe. Take care of yourself. See you in the next section. Bye bye, everyone. Have a good day.